See this, dummy? I want to Elder Scrolls it up. However, if I just put a fancy dress on it, we are right onto clipping through meshland, which obviously is no good. Now, for a sectioned model like this one, it's not too far-fetched to just separate it into pieces and then hide them when needed, or even just hide parts of the mesh through shape keys as we've been doing up until now for these sheets and stuff. However, doing that for a skinned mesh is just begging for trouble, so we need an alternative. And that alternative is masking. Suppose we had a texture with an alpha channel and we just modified the alpha values corresponding to a given set of vertices, so that a section of the mesh would become transparent. Would come in handy in this situation. But modifying a texture like that isn't practical, mostly due to the sheer size of images. As if applying the changes wasn't slow enough, we also have to send the whole pixel buffer up into the GPU. For a single character every once in a while it'd be fine, but that's about it. And anyway, Blender wouldn't be too quick about it. So how do we do vertex colors? That would be the answer. If we have a set of masks per body part we wish to hide, then per mask cache the indices that are transparent, we can then look them up and apply them to a combined mask that can be used for model transparency. A smarter solution, obviously, would be to build an index buffer from the combined mask itself and utilizing this for polygon drawing through the GLDraw elements OpenGL call, with the intent of excluding triangles utilizing the hidden indices from even being drawn. We would only need to update the buffer when the mask itself changes, so we could make this very, very efficient. But I don't think Blender would let us do that. In any case, for poly counts under a few 100,000, it really doesn't make a difference. I'm running on a decade-old, second-hand, piece of shit integrated graphics, and I can attest to that. At the end of the day, you squeeze more performance out of making fewer calls than having less data. The latter only matters when bandwidth is of the actual bottleneck. Though obviously smart use of memory and tightly packed structures are always highly preferred, don't get me wrong. Now tangent aside, I already went ahead and built this from the already existing attachment system. Matter of fact, I built the attachments after implementing this very feature that I have been describing. I just felt like documenting the existence of attachments first, thus creating this time paradox. So now our dummies can play dress up. What's next? We have a little problem with animations, dating back to the last episode if you remember, where combat animations do not enforce the weapon being out of its sheath, and neither do the Peace on Love animations enforce the weapon being sheathed. One difficulty is that although the number of values required to represent states will be the same for each state, this number might very well change, and what the values themselves represent might change as well. The state is effectively a dynamic structure, and this is not something the Blender Python API can do without some coercion on my part. We'll get into that later. So, first step is collection properties. These are, for our purposes, dynamic arrays. Each state will itself be a nested collection, i.e. a two-dimensional array, where each dimension is a variable size. The collection on a state represents the fields of the structure. It consists of two strings. The first one is the full path to an object attribute we wish to reference, and the second one is a stringified representation of the value that ought to be assigned to the referenced attribute when the state is activated. Very important. If you wonder how we will be setting object attributes from strings, let me introduce you to the sacred cornerstone of interpreted programming languages, the one and only eval. Do note that due to the idiotness of Python, I'm forced to use the exact variant to achieve the desired effect, but the explanation of what these do is exactly the same. The point of these built-ins is to take a string and run it just as if you were feeding lines to a console input. A handy feature, if a bit hackish on my part to rely on it, but awful APIs require awful waltz-arounds. Basically, our state consists of a dynamic array of Python one-liners that set arbitrary values. This could theoretically be anything, but for now we'll only really be using them to set shape keys on our attachments. Now we need to associate animations with states. I've chosen to do this with a bool vector, hooking its update attribute to a function that goes through the state mask and runs the Python lines that make up the inner array. Now each animation state mask can be set from the panel and our models update accordingly. So now on to further complications. As it happens, the idea here is that multiple states might be on at the same time, and there's more than one way we could go about combining them. What I'm going to do here is keep it simple and just add an enum property to each field, and from this enum we can derive an operator by fetching from a dictionary. One quirk is that the states with a lower index are effectively lower priority in this chain of operations. Any state you slap on top of them will modify their values. But that goes more or less along the lines of how I wanted this bit to work anyhow, so mission accomplished. Just as a note, remember that these state fields can be used to modify any other value that can be accessed from Python. So likely this will later serve as a bedrock to a whole host of swappable settings. Could be nice. So now we can modify variables across the entire blend file based on which animation is selected for our character. Truly a savage move that takes multi-object animation to a whole new level. I shan't name names, but I really do wonder why the most vocal and critical idiots and tools on the boards tend towards never even considering the very thought of making themselves useful rather than yapping all day. When there are a host of these very clear interface issues left up in the air for mystic rogues such as myself to pick up and fix in their own way, you think that's the kind of thing we'd be doing, but apparently not. I guess we'll never know the answer to these arcane mysteries, but do not despair. I will multiply to the forbidden art of memetics, and my unholy internet offspring shall conquer the world with nihil pointers and superior intellect. Anywho, there's not much else to implement for the basis of this system now. It is likely that it'll be a building on top of it, that I'll be building on top of it to allow for animation modifiers as a cherry on top. But this is all for now, so until the next episode. Ta-ta!